Hi, today I will explain you about the day 4 of 30 days Verilog lecture series. So in day 4 I will explain you how to execute this code, MUX code for 2x1 MUX, 4x1 MUX and 8x1 MUX that I will that I will execute in EDA Playground, Xilinx Vivado, Quartus Prime and Model Sim. First, we'll go with the 2x1 MUX code. So if you see the 2x1 MUX code, this is the code for this module. What is my module name? So MUX21 and input you need to declare input. So you have two inputs I0 I1 and one selection line. Select is the selection line, and output I need to declare with rich data type. Why? Because out I am declaring in the procedural block. That's why I need to declare in the reg data type out output reg out always at the rate star. This is the implication operator. So begin. So this will be applicable for all the inputs. If select, okay, if select equal to 1, then out will be assigned to what? I1, okay, else out will be assigned to I0, okay, end and end module, okay. This is the code, simple code. Depending on the selection line, you already studied in the register, any one of the input is connected to the output for 2x1 MUX. So if selection equal to 1, I1 is connected to out, and if selection equal to 0 and I0 is connected to out, okay. So this is the Verilog code. Coming to test bench module, what is my test bench name? Testbench underscore module underscore 2x1 MUX. So we need to declare the internal variables of the MUX, okay. So I0 I1 and selection I am declaring with reg data type, and out I am declaring to I data type. I need to instantiate my design in the test bench. How to instantiate? So this design name and this design name should match, okay. So design name, so what is my design name? MUX21, and instance name DUT, okay. And next this is the instantiation connection by name. So whatever the variables outside the bracket are design inputs and outputs, and variables inside the bracket are test bench variables, okay. So in order to execute in the EDA playground, so we need to use these two commands, okay. $dump file mux2x1 dot vcd $dump vars 0 comma testbench mux2x1, okay. And you need to give the stimulus. So how to give the stimulus? So I am giving I0 equal to 0, I1 equal to 1 and select equal to 0. So when select equal to 0, so here out is connected to I0, out becomes 0, okay. So after 10 minutes I want to display these values. $display I0 equal to the format specifier %b, I1 equal to %b, selection equal to %b, out equal to %b, comma I0 comma I1 comma select comma out, okay. And after that I am making select equal to 1 for 10 minutes. Now it will take same inputs only, but depending on the selection line, so I1 is connected to out, and I want to display by using this instruction $display, and I want to end the simulation, that is $finish, okay. So this code I am executing in EDA playground. So if you see this EDA playground, so this is the interface. Right side we need to write the design, left side we need to write the test bench, okay. So here so this is my code. Just copy this code and go to EDA playground and paste, and test bench also you copy, and here you paste, and go to tools and simulators, Aldec Rivera, select the Aldec Rivera, and open EP waveform after run, okay. Save this and run this. So the waveform will be open. So depending on the selection line, so when out selection equal to 0, so whatever the I0 is 0, that is connected to out, okay. So when selection equal to 1, here I1 equal to 1, so I1 is connected to out, okay. So you can see in the log file also, here if you see in the log file, here if you see here, I0 equal to 0, I1 equal to 1 and select equal to 0. So out is connected to I0, that is 0. Okay, I1 equal to 0 and I1 equal to 1, select equal to 1, out is connected to I1. What is I1? 1. Okay, so like this we can see in the EDA playground. Okay, next coming to the Vivado. So go to file, project, new project. Okay, let us take, I am giving the project name as multiplexers. Okay, multiplexers, and I need to change the path, no? So we are in day 4. Select this path, next, next, and so whatever the module name is there, same you give as this one. Okay, file name, choose the location. So location is in this multiplexers. Okay, next, this is optional only. Next, next, finish. And my module name is also same. Here my module is created. So go to this code and copy this and paste this. Okay, save this and go to the simulation and create the simulation source. So in the simulation we are going to write the test bench. Okay, so give the test bench file also. So copy this and save, choose the location, multiplexers, select, OK and finish, and OK, yes. So here my test bench file is created. So go to this test bench, copy this and paste here and save. My test bench is instantiated, so this design is instantiated in the test bench. So my design name is MUX21 and the instance name is DUT. Okay, so if you want to see the design, how the tool is converting our code into netlist, gate level netlist, so for that you need to go to elaborate the design. Okay, so tool is converted. This is what 2x1 MUX, 2 inputs I1, I0 and I1 and 1 selection line and 1 output. Okay, so the tool is converting your code into gate level netlist. Okay, in terms of circuit, and go to simulation, run behavioral simulation. You can see the waveforms also. So see here, fit to page. So when selection line equal to 0, whatever the I0 value is there, that is coming to out. When selection line equal to 1, whatever the value of I1, here I1 is 1, so that I1 is coming to out. Okay, so here one second, you can see in the in this TCL console also. So if you see, when I0 equal to 0 and I1 equal to 1, select equal to 0, out is connected as what? I0 equal to what? 0. When I0 equal to 0 and I1 equal to 1, select equal to 1. Okay, out is connected to 1. Okay, whatever the I1 is there, that is connected to out, that is I1. Okay, so like this we can see in the TCL console also. Okay, and coming to the Quartus Prime. So opening the Quartus Prime, new project wizard, and next, and I need to, like, where I need to save this code, so I need to give the path. So here that it is for day 4. So this is my sim folder, this path I am giving, and in the sim folder, so I created 3 folders: RTL, sim and TB. So here I wrote the programs. So how this module name is that same module name you need to give as this file name. So module name is MUX21. Okay. So so project name is what? MUX21. Next, delete the existing and replace this. Okay. And next, so I need to upload that RTL file. Okay. So here, where is my, in day 4 I created one RTL file, MUX2x1 MUX, and so I added that file. Next, just select any FPGA family. Next, next, and finish. As we are seeing synthesis, we need to upload the RTL file. Okay. So go to analysis and start. Analysis and synthesis, start. Yeah, it is successful. And go to this netlist viewer, RTL viewer, and open. So my same as the Vivado, how the circuit is looking like, same like that I got in Quartersprite. Okay. And coming to model sim, so file, project, so go into new project. Okay. So I want to close this project. So project name is what? Let us take